All right, ladies and gentlemen, welcome to the video. We're going to talk about the anterior compartment of the leg. All right, we have 4 muscles to cover. And before we do that, we're going to go through these bony landmarks so you can know what's what and what is the most important bony landmarks for you to know so that you can understand this muscular compartment. So in this image, we have an anterior view of the tibia, and then we have the fibula out here on the lateral side. Okay, your fibula is on the lateral side. And then you can see how they terminate down here to create this mortise, which creates the ankle joint. All right, and then leads into the foot. And so this is a dorsal view of the foot. Okay, so now let's talk about what we have up here. So one of the first things I want to point out is just these two condyles that we have here on either side, right? So we're going to have this condyle over here, which is going to be on the lateral side. So that's going to be our lateral condyle of the tibia, okay? And likewise, we have over here, this is going to be our medial condyle of the tibia, okay? Then we're going to look over here. This is the fibula. The fibula is going to have a head. That's the fibular head, right? Let me write it out for you. Fibular head. And then down here is the fibular neck, okay? Fibular neck. All right. Then over here, we have the attachment site for the quadriceps muscles. That's what was in the previous video for the anterior thigh. So that is going to be our tibial tuberosity. Okay. Next, we look right over here, and this area right over here is where we have the attachment sites for many of the, the sartorius, gracilis, and semitendinosus. All right. So remember that those are the three muscles that attach to this one location, and each muscle is coming from a different compartment of the thigh. So this is going to be our pes anserinus, all right, the goose's foot. Then we have the two shafts, right? So we're going to have a tibial shaft, and then we're going to have the fibular shaft, okay? Then we move distally, and we see that each of these bones is going to terminate to create a malleolus on either side of the ankle joint. Okay, so we have this malleolus over here, which is the one that projects most inferiorly. It projects more inferiorly than the malleolus on this side. Okay, so this over here is going to be our lateral malleolus. Did I spell that right? Malleolus. Okay, and then we have over here our medial malleolus. Okay, and in terms of clinical relevance, your lateral and medial malleoli are attachment sites for the collateral ligaments of the ankle. So a lot of times when people sprain their ankles, it's because they're doing an excessive inversion or eversion of the foot. All right, so inversion of the foot would be the foot basically turning in this way, and eversion of the foot is the foot turning out that way. Okay, and you can do it on yourself right now. And one of the things that you'll notice is that inversion of the foot has a greater range of motion. You could go into a much larger range of motion for inversion. You cannot go into such great range of motion for eversion. And the reason for that is for these malleoli. This lateral malleolus projects further inferiorly. So when you try to evert this foot out this way, this talus and this talus bone is going to hit that lateral malleolus and it's going to stop it. That's a bony block to continued range of motion. Whereas over here, the medial malleolus gives more play. There's more space over here for the foot to go into inversion. Okay, what does that mean? That means if I can go into a larger range of motion for inversion, that will create a tear on the ligaments on this lateral side. That is why the lateral collateral ligaments are more susceptible to being torn than the medial collateral ligaments are. Okay, that's just one reason why. Another reason is just the way that they're constructed. So the medial malleolus has 4 ligaments that create it, whereas the lateral only has 3. All right. All right, let's continue. So now we're going to talk about the bones of the foot. All right. And so this one right here, okay, this is going to be the talus, right? And the talus is the bone of the foot that directly participates in the ankle joint. All right. So it's directly articulating with both the tibia and the fibula. Okay. Then we're going to have distal to the talus. We're going to have this bone right here. That's a boat shaped bone. It's shaped like a boat. All right. This is called the navicular. The navicular bone, right? That's the navicular bone. Distal to the navicular bone, we're gonna have these three bones right here. These three bones right here are known as the cuneiforms, right? Cuneiforms, all right? And that's referring to the Sumerian cuneiforms, where people used to write the stone tablets that the Sumerians used to write upon. And so the original anatomists believed that this looked like those square stone tablets, okay? Whereas the navicular refers to navy or to water, right? And that's why it's a boat-shaped bone. Next, we go over here. This is a cube-shaped bone over here on the lateral side, and it's called a cuboid. Cuboid, all right? That's the cube-shaped bone that we have on the lateral side of the foot. Okay, it's right there. And then we have distal to that. You see that we have all the metatarsals, right? Metatarsal 1, 2, 3, 4, 5. Okay, 5 is for the pinky, the little toe. Okay, and the fifth metatarsal has this large tuberosity that projects out from its base. Okay, and that's going to serve as an attachment site for muscles that are coming from the lateral compartment of the leg. Okay, we're going to talk about that now. That's called, as a mouthful, tuberosity of the fifth metatarsal. Right, tuberosity of the fifth metatarsal, and we're going to see some muscles in the lateral compartment attaching there. All right, so these are the main bony landmarks we need to know. Let's move on to the first muscle, the deepest muscle that we're going to find in the anterior compartment, which is called the Extensor Hallicus Longus. If you watch my videos on the upper extremity, you will know that the big our thumb, right? Our thumb is referred to as pollicis in Latin. When we're talking about the lower extremity, the big toe is referred to as hallucis, right? Hallucis. So every time you see this word hallucis, it's referring to a muscle that is attaching to that big toe, the first toe, all right? So the Extensor Hallicus Longus is going to be a muscle that attaches to that big toe and is going to cause extension of it. Now, where does it originate? So similar to how we saw in the forearm that the radius and the ulna had an interosseous membrane that connects them, we have the same pattern happening here in the lower extremity of the leg. You're going to see the tibia and the fibula connected to each other by an interosseous membrane. Sorry about that. So you're going to see them connected by this interosseous membrane. The interosseous membrane is going to serve as a site of attachment also for these muscles, okay? And another thing I want to point out about this interosseous membrane is that this interosseous membrane, same as how it did in the forearm, it effectively separates the anterior compartment from the posterior compartment, okay? If I were to pierce through this interosseous membrane from the view that we have right now, if I were to pierce through this interosseous membrane, it would lead me directly into the deepest part of the posterior compartment of the leg. Okay, makes sense? So any structure that wants to go to and from anterior, or from anterior to posterior, from posterior to anterior, can get there by going through this interosseous membrane. Okay, now let's talk about this attachment. So Extensor Hallicus Longus is the deepest muscle we're going to find in the anterior leg. It's attached to the middle 1/3 of the interosseous membrane and the fibular shaft. Okay, so it's biased over here to this fibular side, all right, which may be counterintuitive because we see where it's going. It's going from here, from lateral side, but it's going to travel to the toe that's all the way on the medial side of the foot, okay? And so it's going to go to the base of the first distal phalanx, right? It's longus, so it has a long way to travel. It's going to go all the way to that first distal phalanx, which means it's going to have the ability to extend that interphalangeal joint and also the metacarpal phalangeal joint as well. Okay? That is what that muscle is going to be able to do. And when it's in place, it looks like this. Okay? This is what it looks like. Next, we're going to talk about Fibularis Tertius. Fibularis Tertius is a muscle that some people call it a vestigial muscle, say it doesn't really have much function, but it does have a little function. So let's talk about it. So it attaches to the inferior 1/3 of the fibular shaft. It's a small muscle, goes from there, goes straight to the shaft of the fifth metatarsal. All right. And that's going to look like this. Okay. And so looking at how it crosses over the ankle joint, this is actually capable of causing eversion of the foot. Okay. It's capable of causing eversion of the foot or resisting excessive inversion. Okay. All right. Let's move on to the next one. So that was Fibularis Tertius. I need to get this thing over here. Let me get it. So the next muscle we're going to talk about is the Extensor Digitorum Longus. The Extensor Digitorum Longus. All right. It's a beefier muscle. It's going to go to 4 digits. All right. And it's going to start more proximally compared to these two. Okay. So realize we're going more and more superficial. So this real estate right here was taken up. This real estate down here was taken up. So the Extensor Digitorum Longus really can only attach more proximally up here. So it's going to attach to the shaft, to the fibular shaft, and to the proximal portion of that interosseous membrane. In addition to that, it's also going to have fibers attaching to this lateral condyle of the tibia up here, right? And all the way from up here, it's going to run straight down, cross anterior to the ankle joint, and then attach to the middle and distal phalanges of 2 through 5. All right, the middle and distal phalanges of 2 through 5. That's going to be the attachment site for that, and it's going to look like this. All right, so it's going to cause extension of all these toes. That's essentially what it does, and it obviously is going to assist with dorsiflexion of the ankle also. Okay, but it's not the main dorsiflexor, or it's not the most powerful dorsiflexor. The main and most powerful dorsiflexor that we have in the body is the tibialis anterior. Okay, the tibialis anterior. So all this real estate on the fibular shaft was taken up. So the tibialis anterior is going to attach to the tibial shaft and a small portion of the interosseous membrane also. Okay, and then from there, it's going to run down and kind of like curve around the side of the foot, curve around the medial side of the foot to attach onto the medial cuneiform and the base of the first metatarsal. Okay, so that is going to look like this. All right. So this muscle is the main dorsiflexor. It's going to cause a dorsiflexion of the ankle. And in addition to that, since it's running over here and it's biased towards this medial side of the foot, it can pull the foot in medially to invert the foot. All right. It can do that as well. So those are the main functions of the muscles of the anterior compartment of the leg. Gross anatomy is one of the most difficult subjects in the world. Luckily, it doesn't have to be. Anatomy is one of those subjects that needs constant verbal and visual repetition in order to get good at. What better way to reinforce this information than with the scientifically validated method of drawing? Neuroscience has shown us that we retain information better when we physically draw it out. That is why the Gross Anatomy Study Strategy Workbook is designed to walk you through all the layers of the musculoskeletal system, allowing you to draw the muscles into place. This is excellent for reinforcing muscle attachments, bony landmarks, muscle names, and actions. This will save you tons of time from mind-numbing tactics such as repetitive flashcards or passively listening to boring lectures. With this strategy, you can actually begin to enjoy studying again and have a much better way to retrieve the information. Order a copy of the Gross Anatomy Study Strategy today at the link below so you can spend less time being stressed and more time being blessed.